Hello, and welcome to the 7th webinar in our Radiation Safety and Wellness webinar series, Transportation of Nuclear Materials. I'm Lynn McDonald, Liaison Scientist with the Radiation Safety Institute of Canada. Laura Boxman, originally scheduled, had an unexpected emergency this morning, so today I will be joined by Brian Borndal, Director of R6 Fergal Nolan National Laboratories in Saskatoon. Mandel Fraser from Power Yoga West in Prince Edward Island will lead us in our wellness segment beginning at 12:40 Eastern. Let's take a moment to go over the functionality of the Zoom meeting. We ask that during the presentation portion that the audio and video be from the presenters only. We have found that although you can access the audio through the computer or telephone, the quality of sound tends to be better when listening from a computer. If you have technical difficulties, you can contact Maria Costa, who is with us in the chat room today at 1-800-263-5803, extension 321. If you have questions arising from the content, please type them into the chat. As the webinar is only 40 minutes in length and is immediately followed by our wellness session, time may not permit for us to answer all of them during the webinar. The answers will be posted on our website, along with a link to the video recording and a copy of the slides. This can be found under Education Webinars. I'll be sending a confirmation of attendance email after the webinar and will include a link to the page with that communication. I will also include the topics covered and the length of time spent in the webinar, as some people have requested this to send to their professional association. Lastly, I have automatic closed captioning enabled in the slide presentation. If they are being blocked by your Zoom controls, you should be able to select a different way to view the webinar in Zoom, which makes them easier to see. The format for today will be a short presentation giving an overview of jurisdiction and regulation of nuclear materials in Canada, including nuclear substances and radiation devices regulated by the CNSC and NORM as it relates to transportation. This will be followed by an interview of and question and answer with Brian Borndal, MSc PPhys. As time permits, he will answer questions from participants. For the final 20 minutes, Mandel Fraser from Power Yoga West in Prince Edward Island will lead us through stretching and mindfulness practices for the wellness portion. An element is defined by the number of protons in its nucleus. Each element can have a number of different versions or isotopes depending upon how many neutrons are in the nucleus. Stable isotopes do not undergo radioactive decay. Unstable isotopes do undergo radioactive decay. Unstable isotopes are also called radioisotopes, radionuclides, or radioactive materials. There are around 254 stable isotopes and 3,000 radioisotopes. Most of these 3,000 are human-made, only 84 are found in nature. When radioisotopes decay, excess energy is carried away from the nucleus in the form of material particles or packets of pure energy called photons. Due to the damage that nuclear radiation may cause to living tissue, it is closely regulated. For more information on radiation and the health effects from exposure to it, please see our February 4th and February 25th, 2021 webinars, respectively. Jurisdiction and applicable regulations for the transport of nuclear sources and devices depend upon if the radionuclides are natural or human-made, and the source activity, the number of radioactive decays per second it undergoes. For the most part, work with nuclear materials and devices in Canada is regulated by the Canadian Nuclear Safety Commission through the Nuclear Safety and Control Act, or NSCA. The CNSC licenses organizations and individuals to perform certain activities with the substances and devices. The regulations related to transport are called the Packaging and Transport of Nuclear Substances, or PTNS regulations. These regulations refer to Transport Canada's Transportation of Dangerous Good Act and regulations, in particular Class 7. Both sets of regulations refer to the most current version of the IAEA's regulation for the safe transport of radioactive material. If a substance or device does not require a license, then the PTNS regulations do not apply. These exceptions are outlined in sections 5 to 9 of the CNSC's Nuclear Substances and Radiation Devices Regulations. Basically, they do not apply to very low risk sources, devices, and license activities. The CNSC PTNS regulations apply to the entire process of moving radioactive materials around. This includes the packaging and transport of the nuclear substances, the design, production, use, and maintenance of packages meant to contain radioactive materials, the preparation, consigning, handling, loading, carriage, and storage of the nuclear substances during transport, the receipt of the package at its final destination, and the unloading of packages. These regulations do not apply if the nuclear substance is in a person or animal for medical purposes, if the substance is in the remains of a person, to a bioassay sample, a human or animal tissue sample, or a liquid scintillation medium, as the radiation levels in these cases would most likely be very low. If the radiation levels in any of these cases might be high and pose a hazard, it would be best to verify the requirements with the CNSC and have procedures in place. These regulations also do not apply if a licensee is transporting the material within their access-controlled private property for the purpose of the licensed activity. Another case where these regulations do not apply is for consumer products such as smoke detectors or tritium safety signs, where the end user does not require a license. This means that the consumer can take them home without concern for transport regulations. Also, if the nuclear substance is required for a vehicle to operate correctly, that substance does not need to be properly packaged and transported when it's in the place in the vehicle. An example of this is a depleted uranium counterbalance in a gyroscope in an airplane while in use, but not when being transported to or from the aircraft. Finally, natural materials and natural ores with low activity concentrations or other packages where the total activity does not exceed the exempt consignment or the exempt material levels are accepted from these regulations. The exempt activity levels are very low. All this being said, you need to check sections 6 and 7 of the PTNS regulations to make sure the exception applies, as there are exceptions to the exceptions. Transport Canada's Transportation of Dangerous Goods Act and regulations apply to all dangerous goods classes. Radioactive materials are class 7. As mentioned previously, they refer to both the CNSC packaging and transport of nuclear substances regulations and the IAEA regulations for the safe transport of a radioactive material. To properly work with the transportation of nuclear materials, one needs to be knowledgeable and work with all 3 sets of regulations. Also, just as a side note, Transport Canada offers a service to those involved with the transport of dangerous goods called Canutech. Canutech stands for the Canadian Transport Emergency Centre. Shippers can register online to use their free 24-hour emergency telephone number on their dangerous goods shipping documents. If you do so, be sure to receive written confirmation of your registration before using the service. Canutech must be notified for TTG incidents involving rail and may need to be notified in the case of a TTG incident involving a ship. I have mentioned the IAEA several times now, so let's take a moment to explain who they are. An autonomous international organization within the United Nations system, the International Atomic Energy Agency defines itself as the world's central intergovernmental forum for scientific and technical cooperation in the nuclear field. One service it provides to its members are its publications. In addition to individual documents, they have over 50 different series. The regulations for the safe transport of radioactive material document is found within the IAEA Safety Standards series and can be downloaded free of charge from their website. These regulations are not international law, but have been widely adopted around the globe. The transportation of nuclear materials has the potential to involve shipping materials across national borders to and from countries which may have different languages and systems of units. Without a standard expectation, materials might need to be repackaged as they move from one country to another, and shipping documents might need to be prepared differently for each jurisdiction. Countries which choose to follow the IAEA nuclear transportation regulations do not need to worry about these differences because they are using a common international standard. As mentioned previously, there are 84 naturally occurring radioactive isotopes. The term NORM stands for naturally occurring radioactive material. Going back to the CNSC's packaging and transport of nuclear substances regulations, we said that they do not apply to the packaging and transport of a nuclear substance that is naturally occurring, provided the activity was low. How low? It must have a specific activity that is less than or equal to 70 kilobecquerels per kilogram, or an activity concentration that does not exceed 10 times the activity concentration limit for exempt material values set out in the IAEA regulations. When NORM is processed, it can result in a higher concentration of the radioactive material. Such NORM is often referred to as technologically enhanced, or TNORM. Some of the exceptions to the CNSC's packaging and transport of nuclear substances regulations are around the processing and processed natural ores for use in the nuclear energy industry. So what about NORM that is accepted from the CNSC's regulation? Can you just ship it however you wish? The answer is that it depends on the regulations of your province or territory. The Federal Provincial Territorial Radiation Protection Committee, the FPT-RPC, was created to advance the development and harmonization of practices and standards for radiation protection within federal, provincial, and territorial jurisdictions. The Canadian NORM Working Group of the Federal Provincial Territorial Radiation Protection Committee has created the Canadian Guidelines for the Management of Naturally Occurring Radioactive Materials, NORM. To quote, the Canadian Guidelines set out principles and procedures for the detection, classification, handling, and material management of NORM in Canada, and also include guidance for the compliance with federal transportation regulations. These guidelines provide the framework for the development of a more detailed NORM management practices and guidelines by regulatory authorities, affected industries, and specific workplaces. The guidelines are not law unless the province or territory has integrated them into their legislation. So be sure to check with your jurisdiction as to expectations when dealing with NORM. In particular, you may find reference to NORM in regulations related to the environment and/or health and safety, amongst others. This ends the section outlining regulations related to the transportation of nuclear materials in Canada. As we move to the interview and then the Q&A with Brian, we wish to remind everyone that the following conversation does not constitute legal advice. You are responsible to follow the legislation from the applicable regulator. Rather, today is an opportunity for us to learn from Mr. Bjorndal's wealth of experience and for him to give us points for consideration and best practices. The conversation has not been and will not be vetted by the regulators. We will direct detailed questions or requests for comment on specific situations to the relevant jurisdictional regulator. So with that, I would now like to introduce today's guest, Brian Bjorndal. Mr. Bjorndal has an MSc in nuclear physics from the University of Saskatchewan and over 20 years of experience in radiation safety and occupational health and safety in industry, academia, and research. Before joining the Institute, he held positions as Director, Workplace Safety and Environmental Protection with the University of Saskatchewan and Manager, Safety and Radiation with Areva Resources. He managed the Institute's national laboratories during its formative years and was instrumental in the development and licensing of the Institute's personal alpha dosimetry service with the Canadian Nuclear Safety Commission. He returned to us in 2017 and is now the director of the laboratories. We greatly appreciate him being here with us today, especially on such short notice. Hello, Brian. Thank you for being here with us today.
Good morning, everyone, and I hope you can see me and hear me. Glad to be here. I'll try to answer questions that I can answer. I see from the list here, there are some folks here that are probably very experienced in TDG. I see an old colleague, Debbie Fradinger. Good morning, Debbie. She's really an expert in TDG, but I'll do my best to answer the questions I can. And as Lynn indicated, if there's something we don't know the definitive answer to, we can certainly help you find that answer. And but it's certainly, when in doubt, the regulator is the go-to person to make sure that we're safely transporting radioactive materials and what the requirements are. So.
Yeah, so after the interview portion that Brian and I are having, anybody that's in here that might want to contribute and have it more of a conversation type, because, you know, it's a last minute shift. Brian does work with this, but not as often as Laura had. You're more than welcome that we can kind of turn it over to more like a conversation, but let's see how time goes and we'll see where it leads. So, so my introduction that doesn't do justice to your past work history in the industry. Do you mind sharing a bit more about your experience and how you've worked with the transportation of nuclear materials, so people get an idea?
Yeah, no, much of my career has been in radiation safety, starting here at the Institute, and then we're moving over to the uranium mining and milling industry with AREVA. So a lot of transportation that goes on with the transportation of uranium yellowcake. Part of my role with that organization was to be on the emergency response group in the event of a TDG incident, and we did deal with a few of those over the years and during my tenure there. At the University of Saskatchewan, I oversaw the health and safety group, which included the ART radiation protection group, and worked with Debbie Fradinger here, and she was the RSO at the time, and so she did a lot of the TDG things involved with the university, a lot of materials coming and going there. At the Institute here, we do periodically do some shipping and receiving, but we do a lot of training on TDG to help folks get in line with best practices around TDG.
Thanks, Brian. So in the introduction, there was talk about the shipping of materials regulated by the CNSC and the shipping of norm. So to who do these regulations apply?
Well, when you're talking about naturally occurring radioactive material, that's generally not regulated by the CNSC.
Right.
The only time that norm would fall into CNSC regulations in some cases is when it relates to transportation. So if the activity of the material being transported exceeds 70 kilobecquerels per gram or 70 becquerels per gram or 10 times the exempt quantities, then you would have to follow the PTNS regulations. So you would have to look at those particular norm and its activity, its concentration, its surface contamination, if that's applicable, and then determine whether it has to be transported as radioactive material. And if it does, then you are subject to the PTNS regulations and TDG regulations. That doesn't mean you require a license to possess or transport, but you must adhere to those transport regulations. The norm guidelines provide greater detail on what are the requirements and the exemption limits for a transport of norm under certain circumstances. So I would ask folks to refer to the norm guidelines. The PTNS does not deal with that in much detail, but the norm guidelines will provide greater detail on what those limits are for transport, whether it's radioactive or not. So, but yes, norm may fall into that transport regulations.
And for like whether it's the CNSC that's a regulator or whether it's you have to follow what the provincial, you know, you're worried more of a provincial jurisdiction, your norm has to be transported. Who has to worry about the regulations? Is it just the shipper or is it everybody along the chain?
Well, I think it's everybody. I mean, if it falls under the PTNS regulations, then it becomes a radioactive shipment. So, but certainly the owners of the norm, who are the consigners, they're going to have to be aware of what's required and when the regulations will kick in terms of transport of those radioactive material.
Okay, and what about the carriers? Do they have to worry about?
Well, they would have to know too. They'd have to be able
Yeah.
to accept that shipment as well. Yeah.
Okay.
And where is it going is the other question. So again, the receivers wouldn't have to have a license to receive that material, but they're going to have to be cognizant of the content of that material and the fact that it's radioactive.
So that's for the norm, or is that for?
That would be for norm. Well, it would be for certainly if you have a licensed radioactive material that's being transferred, the consignee, the carrier, and the consignor all have to be aware of that. But with norm, you don't need a license to do that kind of the transport. You may need just to follow the regulations.
Okay, so it's a little bit different. There's more expectation in terms of preparation, carrying it along, and receipt if it's not norm.
Yeah, if it's a licensed nuclear material, yes, or device, yeah.
So with the materials licensed under the CNSC, you have to worry about the Transport Canada TGG regulations for Class 7. So why is there two regulators there? Like in terms of the CNSC, what aspects do they kind of look after, and what do you have to worry about with TDG more?
Well, the way I look at it is the TDG regulations are kind of the overarching regulations that govern transport of dangerous goods in Canada, of which Class 7 is part of that. So the TDG regulations provide that umbrella of the general requirements in terms of classification, packaging, labeling, documentation that's required, training of workers, and reporting of incidents, things like that, and also stowage and transport. The PTNS regulations specified by the CNSC really drill down to Class 7 materials. So they talk in more detail about package type, package design, package testing, and classifications. The types of radioactive labels that need to be on the packages, and the radiation measurements that need to be taken, and things like that, and the type of package that needs to be employed. So they drill down and focus only on Class 7. Now, to complicate things even further, the CNSA PTNS regulations refer a lot to the IAEA transport regulations for some of the technical information in terms of activity limits and testing requirements. So the TDG Transport Canada regulations are the overarching. The CNSC ones are specific to Class 7 materials, and they employ heavily or draw heavily on the IAEA regulations for some of the detail in terms of classification, package testing, and things like that. So you really need to have a sense of all three when you're transporting Class 7 materials.
And they're fairly specific, like having taught them before that if you're going to be doing this and never have before, don't expect to be doing it tomorrow. You need to have training, and things have to be very exactly done. So what are these steps in an organization that must be taken before you can ship a package under the CNSC's jurisdiction?
Well, first of all, if we're talking about licensed activity, so if you're in possession of a nuclear material or a radiation device, you're going to have a license to possess that. And out of that license, you're going to have use options in terms of what are you going to do with that. And if you're going to be transporting that device or material at any time or on a regular basis, certainly your license is going to have transport or import or export on it as a activity type. Otherwise, you're not permitted to do that. So you have to have that on your license. As part of that license application, you're going to have an appropriate radiation safety program, which deals with the receipt and transport of radioactive materials. So you're going to have to develop procedures for that and how that will work with the particular radioactive materials that you have. In addition to that, you're going to have to ensure that anybody who's going to be involved with the receipt and transport of radioactive materials at your facility are licensed or have a TDG Class 7 training. So you need documentation. Folks are going to need to be trained on how to manage that, and also how to deal with TDG related emergencies, particularly with the receipt of materials coming into your facility. When you're going to transport materials, part of your procedures will be determining, based on the type of radioactive material, the packages that will be used, the labeling of those materials, the radiation measurements that have to be taken, and things like that. And up to including things like leak tests that may need to be performed on radiation devices with sealed sources in them. If you're going to transport materials, and the simplest one we often see is transporting a nuclear gauge for repair or disposal. Certainly the consignee, who is the recipient of that shipment, has to have a license to be able to receive that. And you have to be able to select a carrier that will accept and transport radioactive materials. You're going to have to keep a lot of documentation regarding that, training documentation, shipping documents that have to be completed, and all the any kind of other tests that may be required as part of the record of that transport, up to including certifications for the type of packages that you're using for that shipment. So if you're using a commercial one, you may have that information readily available. If you're doing you have your own packaging, you're going to have appropriate test information that may need to be presented to the CNSC. If you're using a package that requires a certification by the CNSC, you're going to have that documentation and approval from the CNSC before using that package. So there's a lot of things that fall into place. So if you do transportation of dangerous TDG, or sorry, if you do transportation of class 7 materials a lot, you're going to become quite proficient at it. If you do it only intermittently, it'd be something you have to think about every time you're doing it, for sure. But there's a lot of things to do.
So thanks for that. So you had mentioned that the people that are sending, or the consignor, that they have to have a license, and the consignee, the ones receiving, that they have to have a license. What about the carriers?
No, not generally. They do not have to have a license to carry radioactive materials. There are a few exceptions. The CNSC specifies for high risk types of radioactive material, such as plutonium, things like that. So there are a very few number of instances where the CNSC mandates that the carrier have a license. For most parts, they really focus on the regulations appropriate packaging. So if the materials are appropriately packaged in the right packages and properly labeled, they're generally able to withstand the rigors of transport. So there's only a few instances where we're talking high risk, high activity, and very specific types of materials where the CNSC mandates are licensed. And you can imagine those are often around the nuclear power generation and materials like that.
Right. So if someone is to ship, does that mean any carrier can take them, or?
Not every carrier will, but a lot of the major carriers will take radioactive materials. They do it all the time.
But they would have to have their TDG class 7 and a radiation protection plan, right?
Exactly. So they'd have to have people that are able to familiar with the transport of radioactive materials, the regulations around that. And of course, carriers would have their own internal procedures on how for stowing and what to do in the event of an emergency, if something were to happen with that material. So it's not everybody will pick it up and do it, but they probably have dedicated personnel vehicles for transport of radioactive material.
Of TDG7. So in order to prepare, if we're talking again, the TDG7, not the norm, we're stepping away from norm for a minute. You had kind of gone through it in your answer there, but in general, if someone is preparing a package for shipping, so they have their nuclear substance, step us just briefly through what you have to do in order to get it ready for the carrier.
So you're going to have to look at what is the material you're trying to ship. Is it a sealed source or a device, or is it an open source? What is the activity of that source? And the activity of that source will dictate the type of package that will be required. And this is specified in the IAEA regulations, and they use these. And again, if you don't do this very often, it becomes a little bit mind-numbing, but they do specify activity limits for different classes of packages. And a lot of packages, in fact, most packages are shipped in type A packages. And these are packages that are designed to withstand kind of the general rigors of transport. And so you have to know the type of material and its form. And then from there, you can determine the type of package you will require. If you do a lot of shipping, you're using standard types of materials and equipment, so you may be able to use the same containers that the material was received in, but nonetheless, you have to determine the type of package. And you'll have to have a certified package, if it's not exempt, to hold that shipment. From there, you're going to package it up. If it's an open or unsealed or liquid source, you may need to include absorbent. So this is part of your operating procedures. You'd have to determine the transport index for that material, which is the radiation level around that that package. You'd have to determine or measure the surface dose rate for that, and you'd have to fix the appropriate labels on that package. And I'm going through this very quickly without a lot of detail, but then certainly you'd have to fill out a transportation documentation, which includes the consigner, the consignee, the carrier information, details on the contents of that shipment, including the material, its chemical form, its class, its activity, the TI, the surface dose rates, things like that, as well as any package certification documentation. And certainly that transport document would also have to include a declaration by the consignee or consigner, and any emergency contact information that would be required for that shipment. Once that's all complete, you would have to contact a carrier and arrange for pickup. And certainly most carriers are very diligent, so they're going to look at your documentation, they're going to look at the package and make sure that it aligns with regulations as they understand them before accepting that package. And then it'll go off to the consignee. So before you ship, though, you're going to want to certainly communicate with the consignee that this shipment is coming. And if you're shipping a sealed source in a radiation device, you're likely also going to want to perform a leak test and confirm that the source is intact before shipping. And you may need to provide receipt procedures to the consignee if they don't already have something, so that when they receive the package, they know what's expected and steps to take when it gets to their facility. So that's a very fast run through it.
Yeah, so, like typically when we teach this, it takes a day, right? This is what we can get in 20 minutes.
But you need to specify the type, the form, and then the starting point is what is the type of package that we're going to be shipping it in, because that dictates where you go from there.
And then in some cases there may need to be placards as well, but those are fairly powerful, heavy shipments.
Yeah, so the carriers will have to be responsible for putting placards on their vehicles based on the material that's being shipped. Now, if it's an exempted package, which we've not talked about, and a lot of shipments are shipped under the exempt or accepted under the accepted status. So they're low activity radioactive materials, but they're low risk in terms of transport of them. So if they're considered accepted packages under the IAEA and PTNS, they can be shipped with very little requirements and essentially shipped as non-radioactive. So it's very important to look at that material and determine whether it has to be shipped under all the regulations, or it can be shipped as an accepted package, or if the activity is low enough, it may be exempt and may not have to be shipped as a radioactive material at all. So it's very key to look based on that material to determine where you fall, and that will dictate how many of the regulations you need to consider in terms of shipping that material safely. So determine whether it can be shipped as exempt or an accepted package, or whether it falls under the full umbrella of the PTNS.
Yeah, and you need full training. This webinar does not count as full training. If someone is in charge of the radiation protection program under the CNSC or the norm management program, provincial is requiring that, or territory, what are the types of things they need to keep track of?
Well, I mean, you're going to have dedicated people that are trained in Class 7 if you're regularly receiving and shipping material. So they have to be fully trained and competent in doing those types of activities. The RP or RSO, radiation protection person, whoever it is going to have to oversee those types of activities, make sure that all documentation is maintained, appropriate radiation measurements are being kept, and all documentation related to those shipments are being maintained on file should the CNSC or Transport Canada come and want to investigate or to take a look at those results. Certainly, the staff are also going to want to be trained in what to do in an emergency situation. If a package was to be received, it was damaged, or if there was an incident involving the transport of a radioactive material. Now, that doesn't fall to a lot of folks. So say you had a package that was shipped and a carrier got into an accident, they're likely not going to call you to respond, but they certainly will call you to let you know a package was involved in an accident, or they should. in large facilities, when I worked at Arriva, for example, we had dedicated teams that responded to transport incidents, and it was mostly regarding yellowcake incidents. So on larger organizations that have high risk or large quantities of radioactive material that are being transported, they may have their own emergency response group, and also relationships or partnerships with emergency responders along the transport route. So should something happen in one location, there's folks there that could come out and help with the response to those types of incidents. So in those types of large types of organizations where you have large transports that are going all the time, they're going to have their own emergency response plan and programs.
Yeah,
and with emergency incidents.
And then the CNSC would be involved if there's accidents as well. So,
but if you're shipping your small source or nuclear gauge to for repair, and it was involved in an accident, they're not going to call you out to respond to it. They may inform you that something happened, but the carriers are going to be equipped to deal with many of those incidents. And again, they're going to involve the regulators and other experts as required.
Yeah. So you had talked a little bit about automobile accidents. So I know that was when we were going to ask, but I think that covers it. Inspectors. So what inspectors are involved in the transportation of nuclear materials, and what are their powers?
Well, TDG has a slate of inspectors, and they can come on site anytime, and they can ask to see your training certificates. They can talk to staff. They can ask to review documentation. And so they do have that full kind of breadth of power, and it's always good to cooperate with them and to do the best you can to provide the information they're requesting. So just like a CNSC inspector, they can come on site and they can request all kinds of information, and it's in your best interest to cooperate when they do come.
And the CNSC can check your transport documents as well.
Absolutely, yeah. So if you do, for example, if you are your licensee, part of your ACR annual compliance report will be, depending on the type of license, they'll be asking you, did you transport any types of radioactive materials? So they're going to want a history and some detailed information about what shipments came in and what shipments left your facility. So you're going to have to keep track of that. Now, the ACR is a very not often a high-level detailed document, but it lets them know all the shipments that came and went at your facility onto that license, and then from there they can request to see further details. And it's certainly an auditable point. If the CNSC does come to do an inspection or an audit of your facility and your license, you can almost guarantee they're going to look at that transport information, training, all your information that you have associated with transportation, including the documents. So it's good to ensure you have a clear idea of what you need to record and maintain under your license.
Thanks, Brian. So there's some just questions in chat. Mandel's used to me by now, moving the yoga time back a little bit. So let's just see what we can manage to answer in the next few minutes. I think I have a fair idea of the first one, but you can correct me if I'm wrong. So when importing a Class 7 shipment by air, can the consignee be the carrier who picks up the shipment from the airport? That carrier has the ground shipment document to deliver to the end customer in Canada. Otherwise, can the consignee be the importer of record who never sees the package but has a license for import? In terms of the difference, the carrier typically does not have a license, right? So if it was a Class 7 and it's a CNSC, the consignee has to have a license, the consignor has to have a license, and all three of them, the consignor, carrier, and consignee, have to have a radiation protection program.
Like so, if you were the importer and you had the license and you wanted to pick it up from the airport, I mean, you would have, I mean, no, you'd want to get clarification, but I guess in theory you can, but you'd be subject to all TDG, Transport Canada and PTNS regulations for your shipping vehicle and things like that. So you'd have to, including vehicle placarding and everything like that. So you would, if that was the case, then you'd be subject to follow all those regulations in picking that up and transporting it to either your facility or to an end client.
But in terms of the carrier, typically a carrier would not be made the consignee, because then they would have to have a license. Yeah, and they're not going to take that on. No, in terms of the importer being the consignee, that would probably have to be discussed by the CNSC, because the consignee has to arrange to receive the material and have a license for receiving. So that one's a little bit complicated for sure. I would say the carriers are flat out going to say no. In terms of asking about the importer being the consignee, that might need to be discussed either with your designated officer or the commission if that's who you're in contact with.
Yeah, that's a little bit tricky. You want to make sure you're got clear guidance from them.
Yeah, that's a guidance for the second part of the question from the CNSC. Does X-ray welds in tank construction require special transportation rules for the weld integrity test group? So this is in industrial radiographers, Emil, I assume?
Yeah, so I mean, if they're doing, so it depends. If you're using an X-ray machine, which you can turn on and off, it would be you're transporting it as a device. If you're using, so it wouldn't be subjected to.
But that's X-ray. But if it's X-ray, then that's not CNSC, right? Unless
that's right.
Unless it's over 1 mega electron volt.
Yeah, and if it is also a gamma camera that could be used for doing non-destructive testing, that would be subject to CNSC PTNS regulations. So depending on the type of device you're using to do the imaging, will dictate whether it falls under the PTNS regulations.
Yeah, so if it's an X-ray equipment used for non-destructive testing, that's provincial regulations. You'd have to check with your provincial regulator. If it's CNSC industrial radiography, that there are whole sections on industrial radiography, and the industrial radiography cameras are class B and everything else. So there are some things with industrial radiography specific in these regs. Conditions for transport under special arrangement. Those are very particular. I'd have to dig out the regulations, so I can add that into the document that I send out to everybody. I'll list which regulations have that.
But generally, those are, when we're talking about under special arrangement, we're talking about high activity types of radioactive material where there's high dose rates around the material, high transport indexes, where they have to be have special arrangements and often involve the CNSC involved in the transport. Sometimes a special arrangement could be that you're applying for an exemption on one element of a license, and you've got an equivalent level of safety associated with that transport, which needs to be approved by the CNSC, and that might be transport under a special arrangement. But generally, you're talking about high activity types of sources where.
But I'll list those out in the document with repair afterwards. So keep a look for that, Parth. Rich, in Ontario, just making a comment, we do require transport permit that specifies approved transport of norm. So thanks for letting people know that.
It's an important thing to note on that is that the norm guideline, norm is regulated provincially. Some provinces have more detail on what's expected in terms of norm. Others may just default to radiation dose limits. And they may reference the norm guidelines. But yeah, certainly you're going to want to look at your own province and see if they've got any particular requirements regarding the management and or the transport of norm. So, but generally speaking, if it's below exemption limits, Transport Canada or the CNSC indicate it can be transported as non-radioactive.
Yeah, but then you have to look to provincial if it's norm to check. I don't know, maybe you know this right off the top of your head. William's asking, how does import of norm material from the USA interact with the TDG? The material is not being used for its radioactive properties and thus non-licensed. So that again, provincial regs, right?
So yeah, it would. I mean, it's not, you're not requiring a license to receive it. It would just have to follow the Canadian and US TDG requirements to get it where it's supposed to be.
Now there is some little sections, and again, William, I'll go through and find in the regulations about the CNSC and the import and export of norm. I know that there are a few sections, but I can't quote them right off the top of my head. So I'll find that and pull them out.
Can I add?
I mean,
oh, Debbie, sure.
Can I add to that one?
Yeah.
When it's, I know there's some norm products or rare earth metals that are associated with radioisotopes.
Yes.
And they'll get stopped at the border because it's radioactive. They'll pick that up and you might need an import permit for that.
Okay.
And you would get that from CNSC. You don't need a license per se. It depends on, again, on the radiation levels.
Yeah, yeah, like I was going through exceptions to exceptions and everything else, and I noticed that there is a part about norm with import and export, so that's probably what's sticking in my head. So thanks for that, Debbie. But I'll find it out and we'll do the Q&A, and when I email people out, just go back on link and I'll have the answers to them there. But thanks, Debbie. So with that, Brian, do you have any further piece of advice to people before we move on to the yoga part?
TDG can be quite complex for sure, especially if you only do it intermittently. And it's unfortunate. It's a little bit of a challenge because you have all these, a number of kind of overlaying regulations nationally and internationally. Once you do it for a while, though, you'll get a hang of it. But it's very important to, if that's something you're going to do on a regular basis, that you clearly set out what those kind of procedures are going to be. Based on the materials you have, make sure your staff are trained, and make sure you're keeping all the appropriate regulations associated with any kind of receipt or transport of radioactive materials. And you should be set. The CNSC is very good. They provide a wealth of information, and they've got lots of information on their website. They can certainly help navigate some of the intricacies of transport and some of the oddities, as you've seen, especially when it comes to importing and exporting certain types of materials and what you can and can't do. But if you're in doubt, it's always good to check and confirm your understanding or what needs to be done before you proceed. So the transport carriers are generally pretty good, and they will actually not accept a package that isn't appropriately packaged and labeled with appropriate documentation. So that's good. So they provide, for the most part, they provide another layer of checks on a package that they're going to be carrying out for you. So.
And another thing, just as a comment, that just in my experience with Transport Canada, that they're very responsive to questions and things like that. And it's better to have, they have very high expectations, but they are very responsive. So you have to meet those expectations, and they will help you get there. And just make sure that, like, if you don't do it very often, that it often helps to have a document with checklists of your steps, right? Like when you're freshly trained and you normally do it, if you create a document that these are the steps I go through, then when you have to do it again in 3 or 5 years, or whenever your nuclear gauge goes dead, then you can pull out that document again with a good set of notes. That I would recommend people do that. So with that, Brian, thanks so much for coming in at the last minute. And Debbie, thank you for joining Brian. It's really neat to see that you know one another. And again, we are here. Sorry, I meant to advance the slide. We're here at the Institute, that we have our toll-free information service to provide support questions from everyone, whether it has to do with workplace use of radionuclides, but we also do non-ionizing radiation information, that if you call 1-800-263-5803 or email us at info@radiationsafety.ca, that we will do our best to answer your questions about any types of radiation safety concerns. And if it's a small thing, it's free. If it's larger, we do consulting work. We have training. We have our e-learning site that there's some free courses on there. We have fact sheets. We have information. So check out, if this is your first time kind of hearing from us, check out what we have on our website. We're also on Facebook, Twitter, LinkedIn, and YouTube. So for now, we're going to move on. Mandel, so Brian, thank you very much. You can stay and stretch if you want, but I think you probably are expecting to go back to the lab. Mandel's going to take over, and she's out in PEI, and she will lead us through stretches and mindfulness. And it's important for us to take care of all aspects of our physical well-being. And we encourage anyone that can stay to please join us in whatever capacity you're able. So with that, I'm going to turn it over to Mandel, and I'll shut off my camera and mic once she's ready to go. So, okay, can you talk? I'll tell you if your volume's good.
Yeah, can you hear me?
Not too bad. Is it possible to move the computer just a little closer?
Yeah, I sure can.
Okay.
Sorry to kind of get set up here at the start to make sure everybody can see and hear. How's that?
That's great. Thank you.
Okay, so we're gonna do about 20 minutes of the yoga practice. There'll be some movement to begin with, and then we'll go into a meditation. So movement is just kind of to stretch out, feel good, and then we're gonna come into a loving kindness meditation to finish off. So just make sure you have a bit of space in front of you, but it doesn't have to be a whole lot. You're gonna stay in a chair here, but I just want you to scoot your seat bones a little bit closer towards the edge of the chair. But you should still feel pretty grounded. So feel your seat bones move down into your chair. And as you do that, notice how you just can kind of sit a little bit taller. Feel your feet press into the floor underneath you. So there's some energy in the legs, the lower half of the body. And then I just want you to close your eyes. And for the first few moments here, all we're going to do is focus on the breath. And without shifting or changing the breath just yet, I just want you to notice how it moves into the body, what happens as it moves into the body. And same as the exhale, how does the breath move out of the body? How does it feel as it moves out of the body? And then all we're going to do is we're going to start to stretch out the breath a little bit here. So we're actually going to associate a count with the breath. So we're going to breathe in through the nose. We're going to count to 4. When you finish the inhale breath, there's just going to be a slight little pause at the top. And then the exhale breath will also be 4. So breathing out, count of 4. And then again, just a little pause there at the bottom of the breath. So again, be mindful of your seat bones, grounded down into your chair. Sitting nice and tall, there's some energy in the lower half of the body. Breathe in through the nose. Breathe out through the nose. We're going to start that count now. So as you inhale through the nose, we're going to breathe in for 1, 2, 3, 4. Little pause there at the top. And then breathing out through the nose for 4, 3, 2, and 1. Little pause at the bottom. So again, breathing in through the nostrils, 1, 2, 3, 4, little pause, and breathing out through the nostrils, 4, 3, 2, and 1. We're going to continue with that. So continue counting, breathing in, breathing out. Just a nice, simple, really meditation here. So that it just kind of helps to ground the body, to relax the body, brings greater focus, greater awareness. And the breath really just has this nice way of kind of washing out the body. So getting rid of the things that aren't necessarily needed, the stresses of the day, so far. So we're just going to sit in that breath for a little bit longer here, not too much. But breathing in, 1, 2, 3, 4. Breathing out, 4, 3, 2, and 1. Okay, now I want you to bring your awareness again internally. So maybe feeling a little shift, a little change in the way the breath enters the body, how your body feels as it enters the body. And same for the breath out, if there's any changes or shifts as you breathe out. Might notice now that the breath is getting a little bit deeper. Maybe there's no hesitation or pauses to the breath. It's just a nice long inhale breath. Leading to an exhale breath. Now you can go ahead and drop the count, but just continue to breathe in and out through the nose. Take your hands to your thighs. As you take your next inhale breath, you're just going to begin to arch the spine. So feel the chest drop forward, shoulders drop back. Maybe even the gaze goes up a little there if it feels all right in the neck. As you exhale, you're going to round your spine, so you're going to press your back body towards the back of the chair and tap your chin towards your chest. Do that a few more times. So breathing in, sitting tall, dropping the shoulders back, chest forward, and breathing out, rounding, tucking the chin. 2 more, breathe in. And out. Last one. And breathe out. Come back to a neutral spine, inhale. You're going to keep your right hand either along the right thigh, or you can just kind of drop it along the side of your chair. Left arm is going to reach up, and then you're going to reach it off towards the right side of your rib. Now with that right hand, you're just going to wrap it towards your rib cage. And all you're going to do is you're just going to kind of give a self massage of kind of the fingers in between the rib cage. So getting into kind of that muscle in between each rib. Continue to breathe in and breathe out, working up or either down the rib cage. Just a little massage there. Don't be scared to dig in. Nice way to bring some space for the lungs to move. Take one more inhale breath. One more exhale breath. Bring it back up to center as you inhale. Take both hands up towards the ceiling. Now as you exhale, you're going to press to stand. So you're going to press into your feet. You're going to stand. As you stand up, you're going to take your hands in behind. Clasp onto the hands and just draw the knuckles back. I lost my head there. I'm just going to Okay, now release that. Take the inhale, reach your arms up and overhead. Stand nice and tall. As you exhale, you're going to slowly bring your seat bones back to your chin. Hands to the sides of the body. That's where you'll keep your left hand this time, or take it to the thigh. Right hand reaches up and overhead. And then you're going to take that right arm off towards the left side of the room. Now with the left hand, you'll just take it to the right rib cage. And again, it's just a little self-massage in between each rib, the muscles there. Really just allowing some space for the lungs to expand on the inhale. And when you can expand a little bit more, you just bring more oxygen into the body, which feeds the body cells. Okay, take one more inhale breath. Stay for your exhale breath. Now come back up, take an inhale, both hands are going to reach up towards the ceiling. As you exhale, you're going to press to stand once again. So press into the feet, come on, and just stand nice and strong through the legs. Take your arms, now reach them in behind. Clasp onto the fingers, draw the shoulders back, feel the chest lift. Okay, take a nice deep inhale breath here. Exhale, just slowly begin to release the hands. A big reach of the arms, inhale up and overhead. As you exhale, you're going to make your way back to your chin, nice and slow. Take your arms, pick them up towards the ceiling, inhale. You're going to lean forward just about halfway as you exhale. Inhale here, and then just make your way to your forward fold as you exhale. So allowing the chest to melt heavy on top of the thighs, the head to be heavy, and arms just dangle heavy towards the floor. And now what I want you to do is I just want you to take your hands to the back of your head. Just for a little extra here, you're going to use your hands to tuck your chin towards your chest. So you should even feel now the upper spine kind of open up there a little bit longer. Then let your hands become heavy, so let them fall heavy towards the floor. As you take your next inhale breath, you're going to come all the way up, arms reaching up and overhead. As you exhale, you're going to bring your hands towards heart center. Once your hands are there, you're going to take your right elbow to the inside of your right thigh. And then you'll just kind of push your thigh into your elbow, elbow back into thigh. And as you do that, you'll start to feel the spines begin to rotate off towards the left side of the room. Now, as you breathe, I want you to think on the inhale breath, lengthening through the spine, so nice long spine. There's the inhale. Now, as you exhale, you're going to think about the rotation, so just kind of twisting a little bit deeper. And it's not big physical movements that you're feeling, but just the sensation of the spine lengthening on the inhale and that ringing motion of the spine on the exhale. You're going to take one more inhale. Stay for your exhale breath. Bring the hands back to center as you inhale. And then just come up right through the spine as you exhale. You're going to gather your right knee up in towards your chest, and you'll just grab on in behind the thigh. And now as you take your next inhale breath, you're going to take that right leg, extend it out long. At the same time, you're going to take your toes and point them. Okay, now you're going to bring your knee back in towards your chest. At the same time, you're going to flex that right knee. So as you inhale, it's an extension as you point the toes. As you breathe out, and it comes in towards the belly flex. We'll do that one more time. Breathe in. And breathe out. Now place that right foot on top of your left thigh. Allow that right knee to open up. It doesn't have to be a lot, but you drop that right knee off to the side. Keep your foot flexed to protect the knee joint. Sit tall, breathe in. Now, if you have this spacing and flexibility, you might begin to fold forward as you breathe out. That might feel too intense, so you just stay upright. Again, just focus in on the breath. I'm going to take one more inhale here. Stay for your exhale breath. As you inhale, slowly come back upright if you're holding forward. Gather your right knee back in towards your chest, and then place that right foot onto the mat. Maybe even give that right leg a little shake there. Okay, sit nice and tall. So spine extended, rounding down through the seat bones. Feel a little energy in your feet there. Take an inhale breath. Reach your arms up and overhead. As you exhale, you're going to draw your hands towards heart center. This time you're going to take your left elbow to the inside of your left thigh. You're going to push thigh into elbow, elbow back into thigh. That's going to create the rotation through the spine. And again, using your breath here. So as you inhale, feeling the spine elongate. As you exhale, finding some more rotation. And again, it's not big movement, it's more sensation. Feeling the spine lengthening as you breathe in, rotating as you breathe out. One more inhale breath. Stay for the exhale breath. Bring the hands back towards heart center as you inhale. As you exhale, you're going to gather that left knee in towards the chest, bring your body behind the left thigh. As you breathe in, you're going to start to extend that left leg. At the same time, you're going to point your toes. As you breathe out, draw your knee back in towards your chest as you flex it. So breathing in, extending, pointing. Breathing out, flexing, knee in towards the chest. Two more times. Inhaling. Exhaling. Inhale. And exhale. Next, now you're going to take your left foot on top of your right arm. Again, allow that left knee to open up. Depends on kind of the flexibility of that hip, how much it opens. Don't force it. Keep that knee nice and protected by flexing your foot. Breathe in, find space through the spine, so sit nice and tall. And again, if you have the ability to lean forward and why you feel all right, then that feels so good. So just stay upright. Take one more inhale breath. You're going to stay right where you are for your exhale breath. Lift back up as you inhale. Take your left foot back to your mat as you exhale. Press into the feet. We're going to press this down one more time. You're going to take your arms up and overhead as you inhale. Now, as you exhale, you're just going to sink your hips towards like a chair pose. So almost like you're driving your hips back towards your chair, but you're going over here. Take a nice deep breath in. Just sink a little bit lower, breathe out. And again, press into the legs, stand nice and tall. Inhale, come back to your chair as you exhale. Once seated, take your arms up and overhead, nice deep breath in. You're going to bow forward over the legs as you breathe out. Okay, now as you inhale, you're going to lift your chest up off your thighs, take your arms forward. Hands come together as you exhale, you're going to rise back up. Seating upright. We're going to do that one more time. So as you inhale, you're going to press to stand. Arms are going to reach up and overhead. Here's the inhale. As you exhale, it's going to be chair pose. Stay here, breathe in. Just sink a little bit lower, breathe out. Press to stand, inhale, nice and tall. Exhale, come back to your chair. Nice and slow, no rush. Arms reach up and overhead, breathe in. Bow forward on your breath out. Good. Peel your belly up off your thighs. Arms reach overhead, breathe in. Good. Draw your hands to heart center, breathe out. Take a nice deep inhale. And I just want you to get more comfortable in your chair as you exhale. So you can scoot back, you can lean back. Let your hands just rest in a place that feels kind of more relaxed. Close your eyes and then just focus in on the breath here for a moment. Breathing in, breathing out. So we're going to come into a loving kindness meditation before we finish off the practice here. There's a lot of studies that are being done in meditation and loving kindness specifically on how it just kind of changes the way the brain functions, in the sense that it creates more empathy, it creates more positive emotion, it creates more resilience. So many, many benefits to meditation. So sitting comfortably here, I just want you to focus on 4 phrases and we'll repeat them a few times. So phrase number 1, may you be healthy. Phrase number 2, may you be happy. May you be free from suffering, and may you be filled with peace. So those are the 4 phrases. So sitting comfortably here, I want you to draw to mind a person that you love. So imagine someone that you love sitting in front of you. Feel the energy in your heart space, a positive energy. And we're going to call to mind those 4 phrases again. And you're going to feel as if you're speaking those to the person you love that's sitting in front of you. So that first phrase being, may you be healthy. So you can repeat that. May you be happy. May you be free from suffering. And may you be filled with peace. Now I want you to draw to mind someone that you might have challenges with, whether it's a coworker, family member, or foe. But sending that loving energy their way, again, we'll repeat, imagining that you're speaking these phrases to them. May you be healthy. May you be happy. May you be free from suffering. May you be filled with peace. Now I want you to bring to mind just other humans on this planet. Humans that could use your love, compassion, kindness, and help. Imagine you're sending this loving energy with every breath that they're away. May you be healthy. May you be happy. May you be free from suffering. May you be filled with peace. Now finally, maybe the most challenging one here, I want you to think of yourself. Feeling your heart space with love for yourself. Repeat these sentences, these phrases. May I be healthy. May I be happy. May I be free from suffering. May I be filled with peace. Remembering we are all human. We have the power to learn, to grow, and to love ourselves, people we may have challenges with, our loved ones, and humanity as a whole. Feel that love deep in your heart space. Don't be scared to let it shine. Take a nice deep breath in now. Feel the breath move into every space within the body. Sit just a little bit taller, a little prouder. Might even notice that the heart feels a bit more open now. Slowly begin to open up your eyes. Reach your arms up and overhead. Draw the breath in. You're going to gather your hands to heart center as you breathe out, finishing our practice off with namaste. Thank you for sharing your practice with me today. Enjoy the rest of your day. Take care.
Thanks so much, Mandel. We really appreciate that you make the time to come join us when we have their webinars. So for those that were able to stay to the end, thank you again. We are arranging for another webinar next week, if I'm not mistaken. So keep an eye out. It's going to be on Tuesday next week with Brian again. So thanks again, Mandel. We'll see everybody who can join us next time, and we'll have a few more before the series is done. So with that, we'll give you say goodbye, and I'll have the emails out probably early next week.